Hello everyone. Today I will show the solutions to problems 5 and 6 of round 156 of the Prairie Math League. For problem number 5, at Sarah's school, an A is worth 4 points, a B is worth 3 points, a C is worth 2 points, and a D is worth 1 point. Her GPA in the 4 classes is the total sum of the grades divided by 4. So she's sure that she's going to get an A in statistics, stats, and history, and at least a C in each of biology and physics. For biology, she has a 1/6 chance of getting an A and a 1/4 chance of getting a B. And in physics, she has a 1/4 chance of getting an A and a 1/3 chance of getting a B. These two are independent, physics and biology. And what is the probability that Sarah have a GPA below 3.5? Now, first of all, note that below 3.5 is basically equivalent to a total sum of 3.5 times below 3.5 times 4, or a total sum of below 14. In other words, she's gonna have to get at least 3 off a perfect score of 16 in order to satisfy like having a GPA below 3.5. Now we can use this diagram, since both are independent. We can use this to try to organize the information that we're getting. So for biology, for A, she has a 1/6 chance, and B, she has a 1/4 chance. And we're basically using, along this axis, we're going to use biology. We're going to list things for biology and physics the same. Now, we can, since we have at least a C, that means that we can use complementary counting to find a probability of C in biology and C in physics to be 7/12 and 5/12 respectively. Now, we need at least 3 points deducted from this total of 16. So this thing is like 0 points deducted, 1.2 points. And in this zone, we have 3 and 4, these zones. So what the area we're really looking for is this. And now to finish, we can just take the sum of these 3 rectangles, which represents the area that, like the probability, as denoted by the 2D area. And we can use these, and it's just some area formulas, and we get 13/24. Now for problem number 6, an unfair coin. Hang on. 13/24 is problem E. Forgot to do that. Alright, now we'll move on to problem number 6. An unfair coin lands on tails of a probability of 1/4. When tossed T greater than 1 times, the probability of exactly 2 tails is the same as the probability of landing exactly 3 tails. What is the value of T? So for this kind of problem, it's going to be kind of difficult unless we find the general formula for K tails among N coin flips. So what do I mean? Well, imagine we have N coins here, and let's say K of them are tails. We want to find the probability that K of them are tails. Now, to do so, we're going to find the probability for each of the possible combination of K tails among N coin flips, the probability of that particular combination occurring. Now, for that purpose, there N choose K combinations of K coin flips within N, K tails within N coin flips. So let's focus on this particular one where the tails are in these specific positions. Then we see that the probability of getting the tails is going to be the probability that we get of tail, which is 1/4 to the power of K, because we have K tails, and we're just going to multiply them together. And now we also have to find the heads, which have probability 3/4, and there are N minus K of them, because there are N in total. So this is the general formula. Now all we have to do is do a bit of algebra with 2 tails and 3 tails among a total of T coin flips. So we have this equals this, and we can just expand these combination formulas into this and this. Now, this part and this part, like the denominators completely cancel just by multiplying both sides by 4 to the power of T. And most of this also cancels. The only thing that doesn't cancel is an extra 3 here because of this difference. So this thing cancels, we get an extra 3 on this side, and we see this here. And after a bit of algebra, we get T is equal to 11, which is option B. Thank you for watching.